Well, welcome back to another great night. Our topic tonight is going to be on sequences. So what is a sequence? A sequence is a list of numbers or expressions, either or, usually written with a noticeable pattern. So let me give you an example of a sequence. 2, 4, 6, 8, 10, ... Obviously, it continues on. What sequence do you see? Well, it looks like we're adding 2, adding 2, adding 2, adding 2. So can you guess what the next few numbers would be? You've got it. 12, 14, 16, 18. So here's one very simple sequence. Let me give you an example of another sequence. 10, 5, 5 halves, 5 fourths, 5 eighths. Maybe not as noticeable, but I'm hoping you'll kind of catch it from the first two. How did I get from 10 to 5? Well, maybe you're thinking you subtract 5. Well, does that pattern hold up? Is 5 minus 5 5 halves? Well, of course not. 5 minus 5 is 0. So the pattern of subtracting 5 doesn't hold for this. How else could I go from 10 to 5? Well, besides subtracting 5, I could multiply by a half or divide by 2. So I'm thinking 10 divided by 2, which is the same thing as 10 times 1 half, is 5. 5 divided by 2, or 5 times a half, is 5 halves. 5 halves divided by 2 is really 5 halves times 1 half, which is 5 fourths. 5 fourths divided by 2 or multiplied by a half is 5 eighths. So in this case, our pattern takes place by multiplying by a half, whereas in this first example, our pattern took place by adding 2. So given the sequence, a sub n equals 2n minus 1. So the first thing I want you to do is not only do you have to do math correctly, you have to speak it correctly. This n is lower than a, so it's called a subscript. So let's make a note there. It's a subscript. So it's read a sub n. Sub meaning subscript. A sub n equals 2n minus 1. Okay, so again, we want to speak math correctly as well as perform math correctly. The n stands for the nth term. So the nth term could really mean any term. For example, notice 3 is a subscript. So this is read a sub 3 refers to the, 3 is taking the spot of n, so this would just be the third term. A sub n refers to the nth term. And here is a very special case that you're going to see a lot this year. A sub n minus 1. Well, think about this. If a sub n represents the nth term, and now you take that n and you subtract 1, you're getting the number that was right before it. And we call that the previous term. So the next thing I want to note is that this is called an explicit sequence. A sub n equals 2n minus 1. It is explicitly defined. So part A says find a sub 1. It's a very simple process. Notice the sub 1 is taking the spot of n. So all you do is replace every n you see with the number 1. If there was 10 n's, then you'd plug in 10 1's. So a sub 1 is equal to 2 times 1 minus 1. And now you just perform the math. A sub 1 equals 2 times 1 is 2 minus 1 is 1. Find a sub 2. Same idea. The 2 is taking the place of n, so a sub 2 equals 2 times 2 minus 1. A sub 1 equals, that's 4 minus 1 is 3. A sub 20, I think you've got the hang of it. 20 is taking the place of n. A sub 20 equals 2 times 20 minus 1. So that's 40 minus 1, or 39. Now let's make it a little more interesting. What term? So I want you to underline that word term. They are looking now for the letter n. what term would give you a value of 53? If somebody tells you something has a value of 53, they're basically telling you the answer is 53. So I would say 53 equals 2n minus 1. And the question is, what is this n value that would give you a value of 53? Well, we'll just solve a simple linear equation, add 1. 54 equals 2n. Divide both sides by 2, and I get n equals 27. Same idea. What term, so I'm finding the term, would give me a value of negative 101? So again, they're telling me the answer is negative 101. What is the term that would get me there? So again, I'll add 1 over, so I get negative 100 equals 2n, and the nth term is negative 50. Now that may sound a little odd, but basically we're just going 50 terms backwards, and that value would be negative 101. So the first thing I want you to jot down here are these two different notations. Okay, you'll notice that this is written as a sub n, so this is subscript notation. This is the notation I think you're going to see most often. This is function notation, which you've been dealing with for years now, but they do mean the same thing. They are equivalent to each other. And I have seen in a few algebra books it written this way, maybe even on like some of our practice exams. They do the exact same thing. You replace the n, and you plug your numbers in. So again, I think we'll see subscript notation more often, but be familiar with both. The next thing we have to be familiar with is something called a recursive sequence. So here's our definition. A recursive sequence is a sequence that depends upon the previous term. They must include a given term, usually but not always a sub 1. So they have to give you a term, and then you have to realize that your function depends upon the previous term. And that's what makes recursive recursive. And it's fairly obvious when you see a recursive one. They give you a term, and then they give you something that depends upon the previous one. So let's look at an example here. Let a sub n, and again that's how it's read, a sub n equal a sub n minus 1 plus 5, with a sub 1 equaling negative 2. Find the next 5 terms. So you'll notice it doesn't say find the 5th term. It's not possible to just go get the 5th term, and you'll see why in a moment. So we recall that a sub n minus 1 is the previous term. Now if you just follow the simple pattern, it's really not that difficult. They're giving us a sub 1. So in a recursive pattern, you just need to find the next number. Well, a sub 1 is the first term. That's what the 1 is representing. So the next logical number to find would be a sub 2. So what am I going to do? I'm going to go to my equation, and I'm going to replace every n with the number 2. So I'm going to get a sub, can you do this math in your head? What is 2 minus 1? A sub 1 plus 5. So I know a sub 2 is equal to the previous term, a sub 1, negative 2 plus 5. A sub 2 is equal to 3. Then you go and you find the next term. So let's say I want a sub 3. I'm going to replace all the n's in this equation with the number 3. So a sub 3 equals, and I'm going to do that math in my head, 3 minus 1, so a sub 2 plus 5. And I just found a sub 2 here, so I get 3 plus 5 equals 8. And then I'll get the next one because it asks for the next 5 terms. A sub 4. So I'm just going to carefully go and replace all my n's with the number 4. So I get a sub 4 minus 1 is 3. Notice how I'm using the previous term, plus 5. And that's going to get me, 8 plus 5, so 13. And then I'll go get a sub 5. So plugging in all my the 5's is n. I get a sub 5 minus 1 is 4, plus 5. And a sub 4 is 13 plus 5. So I get 18. And then we'll go get a sub 6. So that's going to be equal to a sub 6 minus 1, so a sub 5 plus 5. So that's going to be 18 plus 5, which is 23. So you can see I used the previous term to get the next 5 terms. So notice this one didn't count. I found the next 5 after that. All right, let's try another example. Write a recursive definition for the sequence 5, 10, 20, 40, 80. Okay, so this time they gave me the sequence and I have to come up with a rule. Now if you look back at your description, a recursive sequence says you have to be given a term, most of the time the first term, and then the rule. So I always start with the first term because that's pretty straightforward. What is the first term in the sequence? Well, if you look at them, the first term is the number 5. So a sub 1 equals 5. Now I have to look for the pattern. And I'm hoping the pattern's fairly obvious. I'm basically just saying, how did I go from 5 to 10? And that same rule has to take me from 10 to 20, 20 to 40, and 40 to 80. Do you think you figured it out? 5 to 10, you can either add 5 or multiply by 2. Well, compare that to the next one. If I add 5, do I get to 20? Of course not. How about if I multiply by 2? That works. Multiply by 2, multiply by 2. As long as it works throughout the whole thing, you know you've got it right. So how do we say it in a recursive sequence? Well, we first defined the first term, which is what we just did. And then we said, okay, a sub n equals the previous term, a sub n minus 1, and then what are you doing to it? You're taking that term and multiplying it by 2. Okay, so again, in a recursive sequence, you need a given, and the previous term has to be involved. So I'm taking the previous term and multiplying by 2 to get that pattern. The next group, explicit or recursive. So again, I think recursive, is fairly obvious because you use a previous term and you have a given term. So if I look at this, given a sub n equals a sub n minus 1, and again, that's the definition of previous, taking the term and the one before it, if I subtract 1, that's the previous term, and then I have a given term. So I would definitely right off the bat say this is recursive. Now they want me to find a sub 4. If I try to plug in a sub 4, I'm not going to be able just to go out and get it. In a recursive, you have to find them in order. So again, if I'm given a sub 1, the next logical term to find is a sub 2. And again, you're going to replace every n, how do I know that? 2 just took the spot of n, with the number 2. And if you can do some math in your head, I'm going to encourage you to do so. When I plug a 2 in place of this n here, I get 2 minus 1, so that becomes a sub 1. I have to square it and add 2. And my previous term, a sub 1, was given is 2. So this is 2 squared plus 2. 2 squared is 4. 4 plus 2 is 6. So I get a sub 2 equals 6. Now again, I'm trying to get a sub 4, so I just keep going in order. So next would be a sub 3. Plug in the 3. So that becomes a sub what? 3 minus 1 is 2. Take that and square it and add 2. A sub 2 we just found here is 6. 6 squared is 36 plus 2. I should get 38. All right, go ahead and get a sub 4. Pause it, see what you get. We'll see if you agree. This turned into a sub 3 for me. I squared it. Well, I took 38 and squared it, and I got 1446 when I added 2 to it. Number 2. Given a sub n equals a sub n minus 1 plus a sub n minus 2, and a sub 1 equals 1, a sub 2 equals 1, find a sub 6. So I guess my question to you right off the bat, explicit or recursive? And again, I'm hoping it's jumping out at you. You're using previous terms by the n minus 1. That's the first previous term. N minus 2 would be the second previous term. So 1 term behind and then 2 terms behind. And again, as soon as I use previous, I know it's recursive. So if I want a sub 6, remember you just can't jump there, you got to go in order. You know a sub 1, you know a sub 2, so logically you should be finding a sub 3. So again, I'm just going to replace all my n's and plug it in carefully. So that's going to be a sub 3 minus 1 is 2, plus a sub 3 minus 2 is 1. So a sub 3 is equal to a sub 2, which is 1, plus a sub 1, which is 1. So I get a sub 3 to equal 2. All right, let's go get a sub 4. So when I carefully plug that in, I get a sub 4 minus 1 is a sub 3, plus a sub 4 minus 2 is 2. A sub 3 we just found here is 2, plus a sub 2, which is given is 1. So I get a value of 3. So again, I want you to pause it and go get a sub 5 and a sub 6, and then we'll compare. Okay, so don't cheat yourself. Good luck. And when you're ready to compare, go ahead and see if we've got the same thing. All right, in our last section here, our goal is to write a recursive definition for the following. So remember, recursive means you need a given and the previous term need to be used. So right off the bat, I always start with that given. A sub 1, the first term in the sequence, is 100. Okay, so now I just got to find the rule. How do I get to the next piece? Well, my first gut always says add. That's the easy method. 100 to 110 means I would be adding 10. Okay, now does that rule work throughout? Well, is 110 plus 10 121? No, shucks, now I have to add 11. And 121 to 133.1, well, clearly I'm not adding the same thing. So I know adding's out. Okay, so if I'm not adding, what must I be doing most likely? And again, it doesn't have to be. You could look for certainly other patterns, but these are the two obvious ones, either adding or multiplying, to always try first. Perhaps I'm multiplying by something. Well, how do I get from 100 to 110? Well, let's just write a simple equation. 100 times what equals 110? That's my question. What am I multiplying 100 by to get to 110? So 100 times, I'm just going to call it r, equals 110. And I want to solve for r. I'm just going to divide both sides by 100. So I get an r value of, what is that? 1.1. So now the question is, does that same r value work? So that was times 1.1. Is 110 times 1.1 121? Grab your calculator, test it out. 110 times 1.1. Why, by golly, it is. Let's see if it works for the next one. Is 121 times 1.1 133.1? It is. So here's my rule. A sub n equals, I'm going to take the previous term, a sub n minus 1, and I'm going to multiply it by 1.1. And there you have a recursive definition. So again, if it's not an obvious multiplication, just say 100 times what equals the next term, and you got it. All right, let's try B. My pattern goes from 18 to 9 to 4.5. So again, my first instinct says subtract. 18 minus 9 is 9. So I'm going to subtract 9 and see if that pattern works. 9 minus 9 is not 4.5. So my idea of subtracting is out again. So let's think of multiplying. I try not to think of dividing. I always try to think of multiplying. Now, certainly you can divide, but I think they're mostly written as multiplication. So again, I just make a little cheat sheet. 18 times what equals 9? Well, divide both sides by 18, and it looks like my r is 9 over 18, which is really 1/2. So let's go ahead and see if that holds. Is 9 times 1/2 equal to 4.5? Well, 9 times 1/2 is really 9 over 2, which is 4.5. So my rule of 1/2 works. So let's write our recursive definition. A sub 1 equals, start with the first term, 18, and then the rule. A sub n equals that previous term, a sub n minus 1, and we said we're going to multiply by 1/2. All right, let's try the next pattern. X, 3x, 5x, 7x. So again, our goal is to write a recursive sequence. So I'm going to do the easy part first. What is a sub 1? Well, a sub 1 is just x. And now I got to look for the pattern. How do I get from x to 3x? Well, I think I'm just going to add 2x. Does that pattern hold? How do I get from 3x to 5x? Well, again, I can add 2x. 5x to 7x? Again, I can add 2x. So it looks like that pattern of adding 2 works. So let's write out the rule. A sub n equals the previous term, a sub n minus 1. And what did we do? Well, we added 2x. All right, you've got D. Come up with the rule. Pause it, see what you get. Perhaps this one isn't as obvious. Well, let's take the easy way. Am I adding? So the first term, I would add 4 to get 7. And then am I adding 4 to get 15? No. So I know adding's out. How about multiplying? 3 times what is equal to 7? So it looks like I'd be multiplying by 7/3. Does that hold true? So if I take this and multiply by 7/3, I get 7. How about 7 times 7/3? Do I get 15? Well, it looks like I get 49/3, which does not equal 15. So wait a minute, multiplying's out. So now you have to get creative. Did anybody get it, you think? How can I get from 3 to 7, 7 to 15, 15 to 31? And again, you can be as creative as you need, as long as your pattern works. So I feel like they're close to being double, don't you? If I double 3, I get 6, which is close. If I double 7, I get 14, which is close. Well, wait a minute, that's 1 away, that's 1 away. If I double 15, I get 30, which is 1 away. If I double 31, I get 62, which is 1 away. I think I've got the pattern. A sub 1 is equal to 3. A sub n, I want to double it, so I want to do 2 times the previous term. And then what? 2 times 3 would get me 6, and then I want to add 1. That would get me 7. Let's see if it works. 7 times 2 is 14, and if I add 1, I get 15. 15 times 2 is 30, and if I add 1, I get 31. 31 times 2 is 62, and if I add 1, I get 63, so by golly, we have got it. Well, that does it for our intro to sequences, and we look forward to some great practice tomorrow. Have a great night.